All right. Hello. Welcome, everyone, to the Compute Over Data Working Group. Thank you so much for joining. This is our 12th session together, Baker's Dozen. And we're fortunate to be joined by Michael Fischer from DBDAO and also Philippe and the team from Polyphene. Michael's going to tell us a lot about the work that he's doing with his database team project. It's really interesting and innovative in the way that it integrates NFTs and blockchain for scientific use cases and a number of other use cases, all built on IPFS and related decentralized technologies. And then from the Polyphene team, we're going to learn more about the work that they are doing around directed acyclical graphs, which has been a big help for the Bacalhau team, all the research they're doing. We're going to be making it publicly available. So if other decentralized compute projects are interested in building out their own workflow management and graph tools to support workflows, these are the folks you want to talk to. So we can go ahead and hand it over. Michael, if you're ready, I'll let you take it from there.
Yeah, thanks so much, Wes. Just to say, I met Wes at in London at DSci. We were both at a DSci event, and we had a really good chat around data and compute over data and everything he's working on at Protocol Labs. And thanks for having me here. Yeah, so I'm working on DBDAO, which is a database or a Firebase sort of for the Web3 audience. And we can think of there's a lot of different Web2 and Web3 equivalents. Like if you need to do a domain name, you use DNS, but if you want to do a Web3 equivalent, you have ENS. And when I started this project, I thought we really need like a database specifically for Web3 applications. So that means around data ownership, that means around interoperability, that means around the tokenomics for allowing people to share data. And so I think in a lot of use cases, we sort of start off at sort of the very technical side. So, but I wanted to sort of kick it off more with like an example of how it's used, and then talk about how it's built in the back end. So just before, here's sort of who I am. I did my undergrad at Stanford, and then I recently finished my PhD. I was studying computer science and AI. My PhD was on how to convert between natural language and code. And now we were using a domain-specific AI for that, but now it's very much being done with these large language models, which is very exciting. I've done a little work in the law. So I was the head TA for California Supreme Court Justice around a class on regulating AI, and from that, I wrote a book on regulating AI over on the right here. And then I also wrote another book recently on formation, which is sort of the legal side of starting a crypto company. So the background here is on this use case is this DBDAO is being used in a lot of DSci applications. So that stands for Decentralized Science. So HairDAO is using this, for example. And the whole idea of DSci is to accelerate science using open protocols and the blockchain to allow easier sharing of data, to allow for people to fund projects more democratically, to allow verification of data. And so in this use case that I'm about to describe, we basically build a ChatGPT bot to augment the scientific research process. And the idea here is we want to see how the intersection between what AI and data sort of looks like. So, the typical research method includes, you ask a question, you develop a hypothesis, you come up with an experiment or some methods. That experiment generates some data, which you then analyze and you sort of write a conclusion on. And we wanted to see, okay, what part of that could be augmented with ChatGPT or AI? So we first asked what ChatGPT, what are the main areas of science? So it says physics, chemistry, biology, earth science, all these different things. And then we say, for each of these different fields, come up with an experiment that uses baking soda and vinegar in each of these fields. So we want to say, I'm up with a baking soda and vinegar experiment for physics, for chemistry, biology, for earth sciences, for astronomy, and so on. And then we say we're just following along in this sort of prescriptive process. We say for each of these things, figure out a way to test that hypothesis, for each of those fields. And it says, for physics, rate how long the volcano erupts for biology, see how the yeast in the baking soda changes things. So we go and we say, okay, we like number 2, which is around chemistry, and we say come up with the methods for chemistry. So we say to test the hypothesis that the acidity level of vinegar affects the chemical reaction between baking soda and vinegar in a volcano, you can follow the following methodology. So it writes out a whole methodological experiment for baking soda and vinegar. And then we say, okay, come up with like an experimental protocol for this. So it comes up with 10 different things that you need to test for. And then we say, write the code. So this is how we start to get into the database side of things. But this is sort of just the example of what DeSci is and why and how you can conduct sort of experiments that use large amounts of data, and why you need like sort of an open source database in order to do this. So we want to be able to replicate this experiment that AI has created across hundreds of nodes so that people can sort of validate this data. So DBDAO, which is the project I'm speaking about, we just say, give it this, this is if you go to a DBDAO's website, you'll see we give an example schema for someone's name and age as an example database. So we tell ChatGPT, here's an example schema database. Now take this protocol that you've written here around the types of the data you want us to collect, the ChatGPT wants us to collect, and take this sort of text and can just given this schema here, convert it into a schema for a database that we can send out to hundreds of people to collect lots of data. So once we do that, it generates this JSON object here, which creates this like user interface for a database, which is on DBDAO. So we can add a row. And when we add a row, we first have to do the scientific experiment. So we actually did the scientific experiment here of doing a volcano, of creating a small volcano, and it works. And we measure the various characteristics. And we fill out the form that it created with the acidity level, the ratio of baking soda, how strong the eruption was, how long it lasted, suggestions for future research, stuff like that. And that creates an NFT row in this database. So what we did back here is when we filled out this survey, what we actually did is we submitted a data point to DBDAO, which is just like a protocol. And DBDAO creates an NFT. And so the person that created this data point is actually the owner of that part, the experiment. So just for the sake of simplicity, you can see this is the data point that is also an NFT. So because it's an NFT, you can purchase this data point on OpenSea. And here is that data point on IPFS. So you have your CID up here and all the different scientific data here. And also it's on Arbitrum. So you can see the hash on the transaction hash. And so now we just for the sake of simplicity, we only use this one data point here. And then we ask ChatGPT to, we export it as a CSV file, and we ask ChatGPT to write up a research report based on that piece of data. And then it sort of writes up this research report. Now, of course, in the future, instead of just one person doing it, you have many, many people contributing data to this database. And that leads to, the ability to verify each data point more, but also, start to analyze the data in new ways that use AI. So for example, HairDAO is using this to collect data on different medications and do different trials with people. And the idea is that, this is sort of an opt-in trial that just people on the internet wanted to contribute to, and it's permissionless. But with permissionless data, people contributing permission data and also being incentivized with the data they contribute, this opens up a whole new set of problems, which we will now talk about. Okay, so just like a little bit going back to what we started with is like, for a lot of things, there's like a Web2 and a Web3 equivalent. So, if you need to store a file, you have S3, but you also have IPFS if you're on Web3. If you're hosting, you use Vercel, but you can also use Fleek. And name service, you have DNS, you have ENS. And, servers, you could write a small server function on AWS Lambda, or you could write a smart contract. And, the database is like the core part of many types of applications. That's sort of where the data is stored and where it's processed. And, we have a lot of things like Firebase, Postgres, and MongoDB. But, the Web3 equivalent there hasn't been a strong Web3 equivalent, and also one that really tries to embrace, crypto economic primitives to allow for data collection. You could just, port over an existing database, but I think what makes the ecosystem work here is really rethinking what are the incentives for data collection, who owns what, and how do you incentivize people, and how do you prevent bad behavior in creating like a Web3 native database. So what if we were building like a Web3 database, what would be some of the things we would definitely want? So the idea that you like put your data into a database and then that's the last you hear of it is sort of passé at this point. People, when they contribute data to a database, should receive a reward for that data if that data is useful. So right now we think of data as costing money to store. So I go to S3, I have a photo, I put the photo on S3, and it costs me a penny a year to store it. But what we really should think about it is like negatively priced data. So I put the data on S3, it monetizes in some way through ads or through subscriptions, and then I get a percentage of that earnings back. And so the idea that data should just be, you store the data, you could choose to just store it and have it private, but you could also choose to have it public and then earn money from that data. So the idea is like you put your data in a database, and if it's useful to people, you're going to earn money back. Data permanence. So data should sort of live forever in a lot of applications, especially in the scientific field. It would be really nice if we had original data for a scientific paper that happened, 100 years ago or 50 years ago, or, if we collect it now, it would be nice if we had that data in 200, 300 years, because then you could try and replicate the experiments. The problem, of course, is that, a lot of databases, when they're in an individual lab, the lab transitions between people, the server crashes, and then the data is lost forever, and you can't really reproduce a lot of the scientific data that happens. Data composability. So right now, like a lot of the databases, because they only use a small namespace, you can't link easily between two data sets. So Tim Berners-Lee is the cool thing is the hyperlink is you could link between web pages. And right now you can't really easily link between databases. But given like Web3 and flat naming structures that IPFS provides, is you can now start to link between pieces of data. You can start to link also, you would also want to be able to link between records in a database. Data ownership. So when you have a row in a database, that row should be yours. And you should have the ability to buy or sell that row to someone else at a future date, or be able to burn it if you want to destroy it. But the important part is that you should have control over it. You don't want to just lob your data over the fence to Facebook or something, and then lose connection to it. Like you should still maintain ownership and the ability to do what you want with it. The cool thing about tokenizing data, of course, is that now your token of data is backed by IP, and you can use DeFi like protocols and lending and staking instead of just having it as a token like an NFT or something that is backed by a picture. Your token is now this data token is now backed by the JSON object within your NFT, and you can now borrow or lend based on the IP that is valued in this token. When you have a data privacy is another thing we'd want in a database, where you could be able to encrypt your row. And then we need identity, where you could tie the piece of data that you have to your wallet and to the reputation that's built on top of your wallet using other services. And then interoperability. So this database should be able to work together with multi-sigs or lending protocols in a way that sort of a Web2 database just can't really easily. So in like one slide, this is kind of like what we do is DBDAO tries to incentivize data curation for structured Web3 data. And so it incentivizes people to bring together data of similar ilk and of a similar schema so that it can later be stored and queried at a later date. So the way we do this is through using we sort of craft the database as a DAO structure. So every piece of data that goes into that is accepted into the database has to go through a DAO first. So the database as a whole is structured as a DAO, and then each individual row within the database is actually an NFT. And we'll talk a little bit about how that works. So how do we incentivize things is we pay out the people that curate the data set, as well as the people that contribute to a data set. So there's sort of there's two main people that get paid, and that is the person who owns the DAO that sort of quote unquote owns the database or started the database, and then the people that contribute to it. And they get paid from people that are viewing the data set. And so the way it works is if you want to view the database, or you basically you can put ads next to it, you can put a subscription model next to it, like Spotify does, or like Netflix does, or ads like Instagram or like Facebook does. And you're basically like selling the data. And then that sale of the data goes to the people that started the database, and then the people that contributed to the database. And so, it sort of tries to align the incentives between the different parties. This is a drop-in replacement. So all the data is SQL queryable. We have SQL interfaces and GraphQL interfaces. And then just like one quick thing on the business thing is like, where is the value here created? So like, there's a lot of crypto protocols you question like why is this useful, and why does it create value? And what we do here is we claim that one individual piece of data isn't alone worth too much. If you have one health record, it's not super useful. But if you compile 1,000 or 10,000 health records together, you have something that's worth more than the sum of their parts. And that more than the sum of their parts is basically the value that's created. And we take that value and then sort of redistribute it back to the people that contributed to the data set. So that's sort of where the value is created and how it's shared between the people in the DAO. So we based this whole project on the ERC 1155 token. And you put here's your X-ray data. You put it into the database. The data is bought by Pfizer or some large drug company, and that pays out, puts the money into the database, and then that pays out the individual person who contributed to the database. And then you take that, then you begin that row in the database has a predictable cash flow. So someone could then take that row in their database and sell it for 10x the yearly income that is generated for it. Now, this introduces an interesting question, because I am now very much incentivized to put as many rows into the database as possible, even rows that might have fake data or that might be spam, because I'm earning sort of a percentage of the income that comes from this database. So if the database is generating $100 and there's 10 people in the database, if I have one row in the database, I can get $10. But if I have 1,000 rows in the database, I will get $99 because I will have weighted it out. So we don't want this. You want to try and protect against people who are Sybil attacking your database. So the incentive, of course, for getting data into the database is you get a percentage of the profits that are generated by the database. Now, we also have to prevent people from putting in bad content. So the way we do that is we make people stake a small amount of money on their row. So when you put your row into the database, you have to put up between a penny and $5, and this is set by the administrator of the database. And so let's just say it's $1. So I submit my data to the database and I put it along with $1 that's submitted. And if the row is accepted into the database, then by the DAO who's controlling the database, and the DAO in this case is a multi-sig of people, and we'll talk more about who's the curator of the database. But right now, the curator of the database is just sort of a black box that takes in a row and either accepts or rejects it. So if the DAO accepts the row, then I get my deposit back. And if the DAO rejects the row, then that deposit gets slashed. And so what's good about this mechanism is that if I am spamming the database, the $1 that I put up, if I'm putting good data into the database, I know my data is good. I will put in the $1. I will then get it back in a day, and it cost me a lot of money. However, if I'm a spammer and I put in 10,000 fake rows, now that's going to cost me $10,000, and all that money is sort of just going to go into funding the database. So I'm not going to do that because I'm going to lose money. So I won't even start to do it. And so that the threat of this works well to disincentivize people from spamming the database. So now we want to talk a little bit about how the DAO works. And the DAO is actually a multi-sig. And so that means it can be one person, it can be a group of people who are part of a DAO project, it can be a jury of people. So you could have 1,000,000 people, 1,000 people in your DAO, and just 5 of them are a subset of 5 of them are always selected to determine if the row should be accepted or rejected from the database. Or it could be a DAO. It could be a DAO. It could be, you could pay people to do it. So you could just have a row accepted. You could pay some random person on Mechanical Turk a penny to decide if this is a good or bad data. Or it could be an AI. So I think this is one of the most interesting use cases. You have ChatGPT be your sort of custom spam filter. You train it on 10 examples, and then it either accepts or rejects the data, and you have then another person who sort of verifies it, who verifies all the flagged pieces of data. So you can also you want to be able to encrypt data. So we use lit protocol to encrypt certain columns. And what's good about this is you basically pay for the decryption key. You pay us, we give you the decryption key, and then you can get access to different columns that are columns in the database. And this might, one example of where this might be useful is, say you had like a list of like leads for sales. You could have their like name and different attributes, like this person lives in this location, this is their name, but you would then encrypt the email column. And in order to be able to contact that person, you would have to pay the decryption. You'd have to pay for the decryption fee, and then you could query on that private column. So I'll give you a short demo of how it works. So we have someone who's building microclimate database on top of it. So we built a UI very similar to Google Forms. So you put in the database name, you put in a small description around the database, and then you put in the field that you were looking to create. So here we put in the location, and it's a required field. Then we go ahead and mint that database. So here's the database as it exists. And we then want to add a row to it. So we add a row. We'll just say Berlin. This is a simple example. That mints that database. You can see that row in the database. We can view the database here on OpenSea, since the database itself is an NFT. So someone can purchase this whole database as an NFT on OpenSea. We can see the Etherscan object for it, and we can see the schema for the database that all rows have to comply to on IPFS. Oops. here. So that's what the database looks like. But then we can also take a look at the row here. So so the row, each row is an NFT as well. So there's the row for the NFT. There's the attribute for Berlin. We can see the Etherscan for it, and we can see the IPFS for it as well. So this this whole database lives on chain, which is cool. And so how does the business model sort of work is the rewards. So the network takes 10% of the revenue. When revenue comes in from ads or through subscriptions, we take 10%. The database admin, the person who started the database, takes 30%. This is a variable reward that's set by them. But it's fixed payout for them based on the work that they do in curating the data. So the curators of a data set need to be paid, and also to advertise the data set and to get people excited about contributing data. So they need to be rewarded. But this is a fee that's fixed. And then the rest of it sort of goes out to the scouts, the people that contributed the data. So if the database generates $100, $30 goes to the $30 goes to the database admin, and then say there's 60 people who contribute data to the database, then each of the 60 people also gets $1. I will take questions in a second, but I just wanted to pitch two other things. We started DSci NYC, which is a Decentralized Science New York City group. If you're interested, here is the web link. We have like 50, 60, 70, 80 people show up each time. And we also started a Decentralized Science Fair where we're trying to do a science fair, but do it on the blockchain. And the idea here is that people should innovate around sort of the scientific process. In normal science fairs, you innovate around the scientific question. But we're seeing in a lot of science that there's some reproducibility issues, and there's issues in the way that science is done, in addition to the research question. So the Decentralized Science Fair is half around innovating in scientific questions, but also half innovating around the scientific process. So if people come up with interesting new ways of conducting science using the blockchain or technology or AI, that's part of how it goes. So if you're interested, here's the website, and you can reach out to me too if you're interested in sponsoring or getting involved as a participant or possibly judge. And if you have any other questions, here is my Telegram and more info on DSci. DBDAO also .xyz is the name of the project. Thank you, guys.
Thank you so much, Michael. Love the vision. Wow, that's a lot, and I think it's really well needed by not only the DSci community, the DAO community, and others. I'll give you one question just to get started, and then I'll give some space for other folks on the call. One of the things that's came up a lot in the decentralized science community and the compute community broadly is this concept of metadata, which you guys handle really well. Folks talk about it in the scientific community for wet lab. What was the humidity when we're doing an experiment? What was the temperature for reproducibility and those sorts of things? Do you think tying it into the work that decentralized scientists might be doing in the future, if they get funding for their research through an IP NFT, and then they're doing some work that leads to drug innovations and breakthroughs and things like that, does the data stored in DBDAO become an important proprietary part of the work that they're doing, or for reproducibility or for other marketing purposes? Is there a tie-in at all?
Yeah, totally. I mean, so all the work, all the data that is stored on, DBDAO is sort of like a protocol. So it's a protocol for querying and storing data. So what you can do is you can take you can create a Merkle tree root at various snapshots in time and saying, okay, this is the data that was generated up until this point that was used to write this paper. And you can say, and then you just put in that root into your PDF. Regarding like metadata, I think in the future, every scientific instrument around, like, if say you have a humidity monitor, that will just either be its own web address that will have various calibration stats next to it, or a person and a device, and that will be just generating data. And every person that generated data into the database, that is then eventually creates useful IP, will be given a percentage of the IP. I don't. Does that sort of answer?
Very helpful.
Okay.
Yes. No, thank you. And I'll give everybody else on the call an opportunity in case they have any questions as well.
Yeah. Thank you, Wes. Thank you, Michael, for a great presentation. Just wondering, yeah, it's a unique design, and what would be the primary goal of DBDAO? Because you want to make data queryable, you want to have this database interface, but in the process, it feels like you create a great data curation system with this system of rewarding the identification of good data compared to spamming rows. So you also, and data curation is super important with this kind of protocol. So what do you try to achieve first?
Yeah, I think the main thing is high quality data. I don't think there's any substitute for quality data around a specific topic. So definitely the main focus is working together with projects that are collecting diverse and need high quality data in order to conduct the research. The SQL queryability is pretty easy to do, and the rewarding is an interesting question because I think there's three things we do. It's like 1 is curation, 2 is rewarding, and 3 is data queryability. And data queryability is pretty easy. And the curation is hard, and working together with people is hard. But then the rewarding one is interesting because I think a lot of the time scientific projects aren't looking to pay people directly. We've talked with a couple projects, and they're not looking to immediately monetize data through USDC or to branch IP between people, just because that's not the vibe of the project. Like the people who are collecting mushroom samples from the woods and identifying them aren't doing it to make a ton of money. They're doing it because they enjoy identifying plants and mushrooms or birds in the forest. So I think the rewarding people through like impact certificates is interesting, and rewarding people is interesting, but it's not sort of the priority that we've seen people adopting it for. But yeah, so that's a good question. I think the main thing is mostly around like having people that don't know each other all opt in to contributing high quality data sets, to creating high quality data sets.
Thank you so much. Yeah, and having these rewards being done programmatically, you foster integration with other protocols, and incentivizing people to store good data won't be done through only subscriptions or like direct incentives, but if you can do that programmatically, then I think you foster integration with other protocols, and it becomes quite interesting. Yeah, thank you, Michael.
Yeah. Good question. Interesting question.
All right. I think we will probably fill up the rest of the time with more questions. I know I definitely have more for you as well, but I want to make sure we give the Polyphene folks a bit of time as well. Michael, thank you so much. We will channel everyone else to go into the Compute Over Data Working Group channel in the Slack, Filecoin Slack channel for additional follow-ups. So I'll sync with you afterwards to make sure they have all the contact information for you.
Cool.
For DBDAO.
Excellent. I will stop sharing here. Good to go. There we go. Thank you. Thanks again, Wes. And yeah, everyone should just only come on by DSci NYC. We're having another one on February 16th, which everyone is invited to.
Very good. Thank you, sir. All right. And then up next, Thomas and Philip, if you guys are ready, we'll let you guys share and take it away.
I'd be glad to. Yeah, thanks again, Michael, for the really nice presentation. Learned a lot of stuff, and it's really interesting to see you work on that. So I will take over for the next 10-15 minutes or so to talk about what we've done as a work for the integration of the Bacalhau network in Airflow and also DAG So to try and have some data lineage on tasks executed over the network. And then Philippe will take over to talk a bit about Holium, which is like our approach to DAG and how we think it could actually be used to create DAG over the backend network. So first off, I want to say thanks to Enrico, which is here today with us. That has been a huge help on our work and with who we've worked quite closely. And yeah, we could do that thanks to him. So the main idea of why we focused on having DAG over the backend network was to be able to track different tasks being executed one after another, and to make sure that we could read data lineage over inputs and outputs from those tasks and the different methods / executions, computations that happen over the network. To do so, we first looked over the Bacalhau Airflow provider. And so this is the job that has been done by Enrico, where he created what's called an operator in Airflow. If not everyone is familiar with it, an operator is in Airflow is actually something that you use to prompt up a task which is one part of your DAG. With which you can, thanks to some input, run some tasks. So it can be a computation, it can be the run of a CLI or anything, and then create some outputs computed from the inputs. And so with this operator here, we could actually run some Docker task over the Bacalhau network, even run some WASM tasks and get some results from them. But what was lacking was the possibility to actually dive into the different operations and making sure that with the proper inputs, we get the proper output, and to try and go back to the root, I would say, of the execution of those tasks. And so to try and create this possibility and to try and create this actually feature over the network, we used something called Open Lineage, which you might all be familiar with it already. And so Open Lineage, what it is, it's Infine, it's a layer on top of Airflow that you can plug, and thanks to a backend that you connect to it, so a DB, let's say, to simplify things, like Marquez, for example, you can actually get some metadata from your different tasks that you run and ensure that you can store them and read them through during the whole computation of the task that you've set for your DAG. Now, what's needed for the whole backend to work and for you to be able to collect the metadata from the task and to make sure that you can read every inputs, methods, and outputs that you've used in your execution? Well, for that, as I said, we need Open Lineage. And so Open Lineage, how do you implement it over Airflow? Well, you implement it thanks to their SDK, and actually only 2 methods, so it's quite simple to integrate. And so what we've done here is actually create a pull request over the current operator that has been created by Enrico. And so the main idea is that to integrate this execution, this metadata layer, what you need to do here is actually implement 2 functions. So wait, let me try to present that in a better way, maybe. Is implement 2 functions. So the first one being here, the get open lineage facets on start, which lets you, before any tasks is executed, so in our case, an execution over the Bacalhau network, we can store metadata inside of our Marquez backend. And the second one is get open lineage facets on complete. And so you can then store metadata once you've executed the task over the Bacalhau network. So it's kind of interesting because it lets us to actually store metadata in the form of CID inputs, for example, if we use IPFS along with Bacalhau. And so store the CID of the inputs that we will use. And once the task is executed, we can actually store the CID of the outputs. Now it has to be noted that those 2 methods are only for a happy path. We do not currently implement, for example, handling of errors or like failed executions or anything like that. Reason being that the current operator that we are working with is something that was created as a POC last year for the gathering in Lisbon. And Enrico is currently implementing a new one. And so we are waiting for this one to be fully complete to make sure that we properly integrate also other cases like failed computations or anything like that. Now, what's interesting with OpenLineage and Marquez is that they get actually pretty well with an interface that's pretty useful. So I'll do the demo right after. I'll just present it to you quite roughly here for now. So the main idea is that we have an interactive playground where we can actually find our DAG. So as you can see here, for example, I have quite a simple one where I can see that it's a simple counter where I generate a number and then I add them one after another. And so with that, I can see that what's happening in my DAG, what I'm storing, what tasks executed, etc. And so we can differentiate here the different jobs that I have, which is computation with little wheel here and the place where we store them. So here we have the counts and here the sums, and so the counter in the end. Now it goes with those diagrams, and we can also see a history of events, where we can see every execution that happened and everything that happens. Now for a quick demo, what I have here today. So I can give you this thing. It's quite public. So if you want to give a look, if you're interested in that, please feel free to look at it. I'll share it right after I finish my part of the presentation. Now I have here a DAG which is running, which is a simple integer sum of Bacalhau. And so it's currently using the operator that is created. As I have a different version between my current Bacalhau client and the Bacalhau client over the server, it's not fully functional, it's not fully working till the end. But still, if I go to my Marquez backend here, I'll be able to see in the events that I have different jobs that are running and that are being stored, and whose metadata are being stored over the Marquez backend. And so for those backend, we can find here, and for those tasks, sorry, we have only 3 of them which are being recorded. So we have number generator here, where we have a lot of different information, quite a lot actually. So from the start date to the task ID that is being run, we can also see what type of task it is. So in our case here, it's a bash operator because we're using bash to generate random number on our local computer. Now, if I go over to, for example, Bacalhau first sum here, we see that we are not anymore in a we're not anymore in a bash operator, we are in a Bacalhau operator, and we are using the Docker run operator here with the task ID first run. Again, I'm sorry, not all the metadata are here right now, demo problem, but it should be appearing. And so the idea is that here in those complete tasks, we'll be able actually to find here inside of the inputs, the different inputs that interest us. And so that would be the client's ID, the input CID and others. While once, for the inputs, once it starts and when it's complete for the output, we'll be able to find the CID of our outputs, and so being able to be redirected to IPFS to look at them. Now, in terms of how we want to integrate Airflow and so metadata collection with our OpenLineage and Marquez over the Bacalhau network, it's still quite under discussion. The problem being that as of now, this needs to be run somewhere. And so a client, for example, as myself, has to run both of those nodes. And so to make sure that we can ensure a proper access to those features to any clients using the public Bacalhau network, it would actually prove useful to run distributed access to such services. And so to have maybe a layer, a new network on top, or new services on top of the Bacalhau network that could provide collection of metadata of any job that needs to be run. So that would be one way to give access to our users to the collection of metadata. Another way to do so would be to consider that our users could actually be people that are already familiar with Airflow, already familiar with OpenLineage and Marquez, and so they could already have their backend running it. And so they could actually have spun multiple instances of those backends and actually collect the metadata for themselves. Now, this is not something that's ideal, because ideally, in the end, what we would like to do would be actually to publish the different DAG information publicly, and to be able to prove that from an execution, from an input and the methods, we produce an output, and to use those triplets of information to be able to share it with anyone else that wants to run the tasks. So I will now hand over the presentation to Philippe, which will talk about a bit more about this vision and where do we think it should go.
Thank you very much, Thomas. Yes, I'll keep it short. I'll try to share my screen. Maybe Thomas, you can give me the hand.
I'll try to.
So Thomas and me, we're talking with triplets of information, input data, method data, and the output of the execution of a method. And actually, I'll take a step back from before working on this Airflow operator integration. We designed, starting in 2021, I think, a protocol we called the Holium protocol. And then we met the Bacalhau team, Enrico, but also Luke and Kai, I think it was a year ago. And we engaged discussion based on this protocol. So right now, what is Holium at the moment? It's a couple of things. It's a design, some specifications, an implementation in Rust, and that can be used through a CLI. And actually, I'll just give you a sense of what Holium is within these 5 minutes. But I would be super glad to first link you to the more complete documentation, and obviously maybe have an informal other session with a tutorial, or maybe get deeper if you're interested in this protocol. So here is a first link that could be probably interesting, holium.org, and documentation is at docs.holium.org, I think. So yeah, we started this design a couple of years ago, and very briefly, where does Holium lies? When we designed it, we were first super interested into DBT as a tool, the pipelines based on the extract, load, transform flow that was gaining quite some attention, but that was just like in the word of SQL constraint transformations. And at the same time, because of our background, Thomas and myself and the rest of the team, we were obviously quite interested into this wave of maybe commoditization of data, this wave of what all blockchains and Web3 enable, and in particular, when it comes to data storage. DBT was pretty useful on private warehouses, and we saw like the convergence of like what could be considered one of the most beautiful public data lake, biggest data lake, and the whole IPFS stack, and an evolution of the SQL constrained ELT pipelines that we wanted to open to more generic ELT. So that's basically where Holium lies. I'll give you a sense of how we built it, but I'll be very brief. We like to compare this protocol to DBT on three layers. First, I'll address the execution environment. Here I take the example of we proceed executing pipelines with executing similar tasks and steps, and here I take the example of a simple Euclidean division. And in DBT, transformations are done in database. We're using SQL, but in our case, for many reasons, we wanted transformations to be written in many languages. We wanted to foster interoperability. We wanted to make these tasks like individual elements of modular pipelines, and so we simply used in the design a containerization solution, and we chose at the time to go with a WASM execution environment. So once you make this choice, you also have to standardize the interface between two steps of a pipeline, and that's a role that is played by SQL models in DBT. And for the sake of brevity, I simplify it saying that you know, all transformations in this design are transformations from one JSON object to another JSON object that can be handled through, like, you know, methods written in many languages. So that's the first step in the comparison with DBT. We use a WebAssembly execution environment. We also had to design another format for data that goes from one task to another, because we want to chain these tasks, and we wanted to, you know, detach any keys from original data. So I'll keep it brief, but what we've done is we've used Cbar, some kind of binary like efficient equivalent to JSON, and we try to remove any keys from this format, trying to find deterministic ways to transform JSON maps into arrays and vice versa. And so that's what we ended up with, what we called the Holium Cbar format. And, you know, starting from there, so we transform, before executing any method, we transform a JSON object into this new format, this Holium Cbar format. And then executing pipelines is just as simple as connecting some outputs from an execution to the input fields of another execution. And so in this example, running the Euclidean algorithm to find the greatest common divisor, we here, you know, we remove any contextual information using Holium Cbar, and we just connect inputs with outputs. So that's the second part of the comparison. And obviously, in the end, we wanted it to lie on the IPFS stack. There's many reasons for that, and what was of prime interest for us was to use CIDs and design the right IPLD schemas, the interplanetary linked data schemas, for it to be understandable, interoperable, and so that's why what we did essentially with Holium Cbar, you have scalar and recursive data. All scalar data is identified through unique CIDs, and then all arrays are just arrays of CIDs. And so here you have a way to identify quite efficiently any piece of data, either integers, but also, you know, floats, text, strings, anything with CIDs. Any recursive data is also based on CIDs. And what's interesting is that obviously bytecode, but also like metadata used by the protocol itself, like pipelines definitions, simply is identified through singular CIDs. So unfortunately, I won't get deeper today, but I hope it gives you a sense of what the Holium protocol we designed a couple of years ago intended to be, what it led us to with these discussions with Enrico and the Airflow operators we're designing today. Here are a couple of links where you can find more information on this project that is now, you know, quite paused, but still useful to design things we do with Enrico and the Bacalhau team today. And there's some areas of improvements, obviously, but what could be interesting, please ping us on Slack if we were to maybe organize another session with a tutorial how to use the CLI, how to get into the first implementation we did in Rust. That could prove useful, I think. So thank you for your attention, and thank you, Wes, for letting us speak today.
Yes, thank you so much for sharing all the learnings there. I love the approach you guys are taking with ETL on immutable data sets.
Thanks. Yeah, I think there's there are so many things we want to do at the same time, but what is super good with Enrico's work is that they have a practical approach, I think, and that actually what they do at the same time they're doing it, they're trying to see how people could use it, and so slowly but surely we're creating something that is useful and that works at the same time. So compared to previous experiences we had with Holium, for instance, now we're creating as a community something that should be useful and could be quite powerful, I think.
Completely agree. Finding the right use case is so key. All right. Well, if no one else has any other questions, we can wrap up. And thank you very much, Michael, Thomas, Philippe, for joining today. Tremendous content. We're going to post this on YouTube shortly, and then we will get continue the conversation. If anyone listening would like to go to the filecoin.io/Slack URL, they can join the Filecoin public Slack channel. Then they can navigate to #ComputeOverData-WG. We'd love to get your input on all these shared topics that we're talking about. So thanks everyone for joining, and we'll see you in the next couple of weeks. All right. Bye-bye.
Thank you all. Bye.